All right. So, as many of you know, I'm Renderman, and I have a distinct pleasure of moderating this panel and introduction to microcontrollers. And I cannot believe that every seat seems to be filled here.
It's pretty crazy.
So you probably recognize...
What's that? The pressure is on.
Yeah, I mean, I'm not wearing pants, so this just gets a lot more interesting.
You flirt with your wife.
And your crotch is right at the level of Joe's giant red fist.
Excuse me a moment.
It's going to be one of those kinds of panels, apparently.
Yeah, you don't want to know what's going on behind this podium here. So on my left, is that my left? Yes, that's my left. We have firmwares. We have Lost, who everybody should know, and I have a personal grudge against for the number of years of torture from the Mystery Challenge.
Oh, yeah.
All right, we got Smitty Halibut on the end here, in his very epic hat and custom-made vest. And Joe Grand, which...
I'd like to correct that, Render. That's TV's Joe Grand.
Oh, TV's Joe Grand. Yeah, Discovery Channel. Yeah.
Yes. Thank you. Please, no applause, please.
So we're basically here talking microcontrollers. I'm elated because I get to pick these guys' brains for an hour here. That is something I would have killed for at any other time. So basically, we're just going to go down and just sort of have everybody sort of introduce how they got into micros and just sort of their history. And we'll go from there. So, firmwares?
Wow. So, I started hacking code on an Altair 8800B, and like a lot of you guys, I loved, writing software, but it's I wanted to do hardware stuff. And so I ended up with, back in the day of 8051 microcontrollers, and that was all for fun, and ended up being an embedded systems engineer, making my way up to being a VP of engineering for a contract design house. So I love making hardware that does something, and some of it has blown stuff up, and some of it has helped people live, so it's probably a good balance.
Yeah. Kind of a 50-50 thing there.
Kind of a net zero.
Yeah.
So my first foray into the world of microcontrollers was with the Motorola 68HC11. Anybody in the audience remember that chip? Yeah.
Oh, yeah.
We just dated ourselves, right?
Yep.
Yeah, the 80s called, they want their street cred back.
So I've just always been interested in how things work, not just electronics, but just things in general. As a kid, I was always taking stuff apart and occasionally able to put it back together, usually things hacked to have different functionality. I've had numerous jobs over the years. I've worked for Parallax. I've worked as a design consultant for companies doing embedded systems, and specifically embedded system security, because that's kind of where my interests lie. So.
And you have some experience with some badge design.
A little, not as much as Joe.
Not yet.
Not yet. Working on that.
Me? Okay. Yeah. So I'm Joe Grand.
TV's Joe Grand.
TV's
Thank
Joe
you.
Grand.
So please, no applause, please. Yeah. So I got started with computers and electronics really early. In 1982 with an Atari 400. And my brother was luckily interested in this type of stuff, so he sort of threw all these tools at me and electronics, and he didn't literally hit me, but I kind of was exposed to a lot of electronics at an early age, which was cool. So I first started getting involved in kind of non-microcontroller development, so making boards for red boxes and blue boxes and various phone freaking stuff.
I think the statute of limitations is up. We can talk about
It's probably
that.
up, yeah. But I got involved in embedded development kind of in my teenage years and in college. So I was sort of a Motorola HC05, HC08 guy for a while, and then got involved with microchip picks and sort of stayed with those. Motorola spun off into Freescale, so I went over and started using Freescale stuff. But if you guys noticed, for Defcon 14 badge was a microchip pick, and then 15 through 18 was all Freescale, and that was mostly because they would just take me out to dinner more than microchip did. So yeah,
Fastest way to Joe Grand's heart is through his stomach.
Free food, pretty much, guys. So remember that. Yeah, so I sort of specialized in embedded system development of kind of low end consumer and household devices, and then of course I do hardware security. I break stuff once in a while too.
Yeah.
So interesting side note, Joe. Do you realize that some of the products that you would submit to Parallax for sale, that I was the one that was actually looking at them with John Barrowman?
I know, yeah.
And so that's
Ryan was
kinda
in control of my destiny.
That's how kind of Joe and I met. And so like before we met through Defcon, like I was looking at his products, I think it was the GPS module.
Probably a GPS.
When we were having that
before GPS was easy to deal with.
Yeah, and we were standing outside, and I think was it John Williams that was busting your balls about something? I just remember a funny interaction that we had, and you were going.
And I don't know. I think Ryan was at DEF CON and I was at DEF CON, but I don't know if we knew each other. And it was like, you work at Parallax? Weird. But yeah, it's a small, sort of like the embedded world is kind of a small community, I think.
And for the record, I do not work for Parallax anymore.
No.
So I think the first question for everyone.
What? And this guy over here. I'm good. Here, let me give you some water. Hold on, have some water.
And the funny thing is Smitty is the one who put this whole thing together.
Yeah, this whole panel was my idea. I'm not sure how I got convinced these heavies to do this panel with me. My name is Mark Smith, or Smitty. I'm the only one up here who does not do microcontrollers professionally. So I'm a hobbyist with my microcontrollers. I spend most of my time on Atmels these days.
Thank you for saying Atmel and not saying the other A word.
What,
I'm sure it will come up.
Okay.
I'm waiting for that.
I spend the Arduino word. Mm-hmm. Yes, okay.
That will come up.
Ooh, good Lord, we got a bad reception on that one. But I got my start in computers when I was at a very young age. My oldest sister got a TRS-80 Model 1. Can any of you beat that?
Yeah.
Actually, no, I think the 8800 beats that, yeah. So I started on that just doing basic. I didn't get into assembly until college in the early 90s. My first microcontroller work was on an 8051, but I didn't spend a lot of time at Intel because Intel assembly sucks. And I'm a hobbyist. I am a network engineer and system administrator by trade, and I just do this on the weekends for fun because I like making stuff and I like making things that work. And I've been into electronics for a long time, and then once microcontrollers started getting really cheap in the 90s, that's when I got into adding programmability to my projects. So,
All right. Yeah. So,
And thanks for putting this panel together, by the way, Smitty.
Yeah.
yes. What was that? Shit, you're welcome.
So everyone who's not played with microcontrollers or is just starting like I am, initially it's the question of where do you start? Because it is such a huge field and so many platforms, so many development tools out there. How the hell are you supposed to know where to begin? And I know some of you guys actually like teach classes on this. Where is a good place to kind of start and learn this?
Should we just go down the line?
Okay.
Let's just talk.
Okay.
Yeah.
Well, yeah, I think that's definitely like people come up to me and ask the same thing. It's like there's so many different choices, and the good thing about nowadays is that there are so many choices, right? Like back in the day, if you wanted to get into microcontroller development, you had to get the individual microcontroller, deal with the development environment, add a bunch of external stuff just to get the part up.
The programmers, the platform, the memory, everything else.
And then you were writing like assembly, hoping that it was going to work. So now it's like you have, Arduino platforms, you have Propeller processor, you have all these other modules, Raspberry Pi and the BeagleBone and all of these things. And it sort of depends, I think, on what you want to do with that device, right? Because there's so many different flavors and so many different levels. If you're doing something basic, maybe use a basic stamp, or if you're doing an Arduino. If you're doing something complicated, maybe do Raspberry Pi, which is Linux based. So now you can write all sorts of Linux stuff. So you don't even have to be a hardware guy. You can just write code and have stuff work on the hardware on the hardware. So yeah, it totally depends on what you're doing. And then you can always go to...
I agree. It depends on what you're doing. But for somebody who's new, it also depends on the tool chain for me. Yeah. Because I can't take a noob and drop them into certain tool chains that are like slamming your nuts in a door. Like certain FPGA development software packages, for lack of a better word, are not exactly user-friendly.
Yeah. Well, I think a lot of engineering tools suck anyway, right? So you just have to find the one that sucks
definitely
the least.
Yeah, you mentioned the A word, but the one thing that I think Arduino has above many of the other platforms is that it is meant for artists, not for engineers.
Right.
And so the thing that Arduino did that made it so popular is that they made everything so incredibly simple and trivial to use. You don't have to buy a programmer. The programmer's on the board itself.
So the only problem I had with the Arduino and the Arduino zealots, I don't have any problem with AVR.
To be clear, I am not a zealot.
Yeah. No, I get that. The thing that frustrates me is they talk as though it's the first time it's been done because there was a lot of money. O'Reilly and the maker crowd started backing it. And, you've got processing and you've got the environment. But they're not doing anything that, like, the basic stamp didn't do for the
stamp.
Yeah. So, I mean, I think really, as far as going that route, the stamp was really the first chip to do that.
Yeah, that's true.
The problem that the stamp has had, and I'm sorry, Parallax people who are out there, is they haven't grown with the way that the user space has grown, and they're still charging $50 for a basic stamp too, and you can't compete at that price point. And I actually have talked to Ken Gracie at Parallax. I was like, Ken, I love the basic stamp, I still do, and on a number of occasions I've even heard Joe say, when I'm prototyping, I still grab for a basic stamp to do proof of concept stuff that's really simple things for off the shelf. But it's ridiculous to charge $50 for that chip these days. Yeah. And I said, if you're gonna stay competitive, at least as far as the stamp is concerned, you're gonna need to lower the price on it. So anyway, I thought that's, I don't mean to be airing dirty laundry, but I think that's the kind of stuff you guys want to hear, right? Yeah.
But I think the Arduino, I mean, people always bash on it, and if there's like an Arduino hack on Hackaday, everyone's like, oh, Arduino lame, and it's sort of like there's definitely this religious war, right? Arduino versus other stuff, just like there was with open source whatever and Linux versus whatever. But I mean, Arduino, for what it is, it's good. If you want to get something done, there's lots of example code out there. There's lots of support from the community versus something like the basic stamp. You have some community support, but you have support directly from Parallax and the engineers and stuff. But the community support tends to be okay. My only problem with Arduino, though, is that a lot of the open source stuff that's out there, the modules that people write, nobody's validating that stuff. You don't know if it's good. And it's sort of a paint by numbers kind of plug stuff together, which is great for prototyping. But once you're done, it's sort of like, if it's a one-off project, that's fine. If you want to move it forward, that's when you have to really start going through and making sure that it's actually good.
Yeah, but with the subject, on the subject of how do you get started, though?
Yeah.
I would rather have somebody who is new to the hobby get an Arduino for $30, plug it in with the USB cables, load up the Blink code, get it functioning, and go, that's fucking awesome.
Okay, but look at the Blink code for an Arduino, and look at the Blink code for BS2. I can put my mom in front of the code for a basic stamp too, and she can understand it. My mom does not do computers.
Or the prop BOE, like Propeller, Board of Education stuff.
Yeah.
But I mean,
So I'm not trying to, like I said, I'm not a zealot. I'm not trying to put the Arduino instead of the basic stamp stuff. I'm definitely not doing that. But I want, so I guess we need to make two categories of the kind of the simpler consumer targeted microcontrollers versus the industrial, I work on this shit all day, I have the programmers and I can write
and Smitty, just as a matter of confession, I've actually sold Arduinos at Defcon before. We sold the Teensy one year. Yeah. So I'm not like anti-Arduino. Yeah. What I'm anti is the attitude of this is the holy grail that has come down from on high to save me from my microcontroller ignorance. That's what I don't
Or the idea that anything else is way too difficult.
Correct.
I don't know how many guys I've said, oh, the Arduino's great because, well, I don't need an in-circuit programmer. Well, until the bootloader blows up. And now you need, and what's an in-circuit programmer? Well, it's just another piece of hardware. You plug it in, you say program. It's not that hard for someone who's used to pushing packets around a network to learn how to use that.
Dude, I mean, even TI's MSP430 toolchain is getting pretty good in terms of being usable. I mean, what do you guys think about that?
But you can't have a beginner load up MSP430 and suddenly know it, right? Like Arduino is a good platform for that.
Sure, yeah.
One of these days, we'll let Render ask another question.
Yeah.
I just wanted to say, I don't want this to be like me leading questions. There's a microphone here. We want to hear from you guys too. So if you've got...
Get us to shut up. Ask us more questions. Otherwise, we'll just keep here bitching all day. So...
one question I do want to get to here.
Walk up to the microphone.
Oh, it's going to be hard. Microphone. You're going to have to stage dive over to the microphone.
One question I wanted to say was one of the biggest difficulties I've had in getting into it is you get the idea and you want to go and build it, but oh crap, now I've got to do a DigiKey order, a SparkFun order, or something like that, and you got to wait weeks because I'm up in Canada. You gotta wait weeks.
Well, that's your problem.
No, I'm just cheap and don't want to pay FedEx.
So one of the things I used to tell my students for getting started for saving money is you can usually get engineering samples from Microchip a lot easier than just about anywhere. And
and that's the question is, inevitably you end up with all these parts bins and everything like that, but the problem is, sinking a huge amount of money into that. Is there like shortcuts or ways like engineering samples to get
Yeah.
that base stuff.
Constantly harvest, like pretend you're a squirrel and just start gathering stuff.
Yeah.
And I mean, vendors will basically, if vendors think they're going to make money, they'll give you free stuff. But if they think you're doing something cool, they'll also give you free stuff, right? Because then it gives them, there's something they can promote and they can write about on Twitter or whatever. And to give a few samples out to a hobbyist isn't going to kill them. It's only going to help. So for the most part, you can get free stuff, but always scavenge. Like I live in San Francisco, and there's kind of this weird kind of cycle of people put stuff on the street, and then you can take stuff from the street and like put other stuff on the street. It's weird. Sometimes it makes neighborhoods look really shitty, but other times it's awesome. Like if you can get there before the city comes to pick everything up. So I will always walk around and be like, oh, a printer. Like I wonder if there's EPROMs in there I can use, and just sort of scavenge and harvest.
Yeah.
And of course, go into like your local surplus stores and electronics flea markets. Like you don't have to pay full price for things, but even if you do, most of the time full price is like pennies or a few dollars for stuff, unless you live in Canada.
And make friends with engineers, because all of my engineers had desks that were filled with samples that they were never going to use. Oh, this part is so cool, and I can call up the distributor and get it. But scavenging parts, I mean, hell, that's how I learned how to solder. I didn't have any money for parts, and it's a lot harder these days with the surface mount stuff. But back in the through-hole day, that's how I got parts.
And in the worst case, Radio Shack. I know they had I'm serious. I'm dead serious. They got a really bad reputation over the last 5 or 10 years when they got rid of a lot of their electronic stuff. But they always kept that one little section where you could get resistors and capacitors and stuff. It's like 9/10 of the store is selling cell phones, but they still have that one drawer of components.
That's like the last resort.
It's the last resort. So at 8:30 at night, my DSL modem just died, and I have an exploded capacitor inside my DSL modem's power supply. I could still go down to Radio Shack and buy that 35 volt, 660 microfarad capacitor to get my internet back online, so my wife can watch Game of Thrones. Yeah. All right. So Radio Shack, and they're also getting into selling things. Thank you, sir. I got a fan out here. Very good. They're also getting into selling microcontrollers like the A-Word and Basic Stamp and
a lot of modules and stuff.
A lot of modules.
That's not a price.
I totally didn't mean for you to start saying the A-word instead of
but they're not the cheapest around, but when you need it right bloody now, they're there. So I wanted to throw that out. No,
well, the fact that they have the modules now, I mean, that's what hardware...
That's recent, and I love it.
Well, hardware's come, a full circle as a hobby. I mean, back when I got into it, we built kits and everything. It was Heath kit and all that. Mm-hmm. And it died out when computers got big. Electronics nearly went away as a hobby because, well, why do I want to do all this hard stuff and get ferric chloride all over my hands and etch boards when I can write code? And I can write code and compile. Oh, it fucked up. Oh, okay, compile it again. Yeah. It didn't cost you anything.
And it's actually moving more towards that with the advent of FPGAs coming down in price now. Yeah, because now I can, just
recompile the hardware. Yeah. And now electronics as a hobby, it's more of a systems level hobby where, some of us still build our own boards and so forth, but there's so many modules out there now, you really don't have to do that.
That's true.
It's like Legos.
All right, we had a question.
Yeah.
What do you do whenever you're up against a particularly crappy tool chain? What's your method of attack to get past that?
Cry.
A lot of Mountain Dew.
I shoot things.
I think it depends. Like, I've had really crappy tool chains, and I mean, sometimes you're stuck, right? If that's all that the vendor offers you, if I have a contact to the vendor, I'll talk to them and say, your tool chain sucks. You got to try to do something with it. But most of the time I'm spent dealing with the crappy tool chain and, saving often and exiting and loading. And usually when I talk about crappy tool chain, what I've sort of encountered is the tool will crash or it will disconnect from the debugger or something just annoying that you have to just restart. And that's, I think, the nature of engineering tools, because they're designed for engineers, and they're not designed for the mass public, so they don't go through the testing as like a normal piece of software would. They're just annoying and sometimes crappy, but as long as they end up compiling properly and working properly sometimes, sort of like that's what you get.
On the hardware side of that, I don't use KiCad anymore because they pissed me off from crashing and losing my code too many times, my board designs. I got another a single guy. All right, thank you. I got to buy you a beer afterwards.
Hey, Joe just claps at everything you say.
Yeah, apparently. I got a fan.
Joe, did you hear that when I was doing this stuff for the badges this year, I actually used the free version of Eagle because I wanted everyone that was here to be able to recreate the badges with free software off the shelf. And I found an error in Eagle that says too many pixels in the Y direction. And it says it in German on the bottom as well. And so I took the work and I rotated it to try and see if I could recreate the error in the other direction, and it doesn't exist in the other direction.
And now everyone can just make their own black badges. But they don't have the clock
if
based on it.
Yeah, if they can do the mechanical watch movement and make that, then they deserve a black.
All right, next question.
All right. Yeah, so I wanted to ask you guys what do you think the best chip is for like DSP, kind of like audio?
All right, religious war.
Live audio processing. Or
DSP
not the best,
audio.
but maybe the best one to start with, you know.
Oh, for DSP.
For DSP and audio stuff?
Yeah,
one you already have
live
code
audio
for.
processing.
I got nothing.
The one you already have code for. I mean, you know, from a professional's viewpoint, right? Well, this one's cheaper. Oh, this one's faster. Well, yeah, but how does that equate to, you know, a few hundred hours of engineering time? And if you've got code, if you can find code that does what you want to do as a project, you know, that whole question, where do I start? Well, find a project that's similar to where you want to go.
Or find a vendor that has the reference code or an application note for where you want to go.
Well, make really good friends with the FAEs.
Yeah, the only experience I have with DSP stuff is the Defcon 17 badge had a digital signal controller. So it was sort of a microcontroller that had internal peripherals, but it also had DSP functionality. That's the only one I know of.
That one was
and
cool.
there was like, actually, the tool is sort of cool. The tool set, it's not open source or anything, but it's free. And you can, which is, to me, fine, good enough. It's even better than open source if it's free. There was one thing called the processor expert, and you could actually select modules and say, I want to implement an FFT, and you double click and there's a GUI and you can set it all up, and that will configure all the DSP side of things. And you could do like a modem, like some old school 1200 baud BPSK or whatever it was modem. So that's a good place to start. But yeah, I'm sure there's a reference design somewhere or a project that does something similar to what you want to do.
That's actually, I do a lot of audio work, audio electronic stuff as well as digital, and that's generally where I'll start out. I'll look at the different chips and look for, they'll have like the application note in there of, this is a typical application for this chip, and I'll try and find one that matches closely what I'm trying to do, and that's generally how
Do you have to do that while standing right behind me? That just looks awful.
All of a sudden, Render feels like he needs to
It sounds
pee.
like Render's peeing.
So follow up, is there like a resource that I can go to kind of like browse through all these different chip examples? And
Google.
You just
Google.
There's this thing called the internet.
I mean, they're all going. Each of the different vendors are going to have their own site, and they're going to have their own list of things, and they're going to talk about why their chip is awesome. They don't necessarily say better than the competitor because they don't want to acknowledge that the competitor exists, but they'll say, we're awesome because we have all of these things. And you go to their competitor, and they're say, we're awesome because we have all of these same things. And you look at the list, and they're like 95% overlap, and
That's why you just see which one takes you out to dinner more.
yeah, exactly. Free food, always a plus.
As far as searching for parts, though, do you guys use Octopart a lot? Have you used Octopart?
Yeah, Octopart's cool, but you have to that doesn't give you really it gives you data sheets, but it's not as easy as like a parametric search on a vendor site.
Yeah, I get it.
Yeah.
Octopart basically will tell you which distributors have stock of the current part you're searching for and then give you data sheets. But if you search for DSP, you might see stuff, but you can also just go to DigiKey and do a search and then, organize by price or by some feature and see which ones come up.
Mauser's search engine works much better than DigiKey's in my opinion.
Yeah, so
Mauser's is much better.
other than the big dogs, DigiKey, Mauser, Jameco, and places like Electronics, Goldmine, and stuff like that. Are there any other major houses you guys order from?
Jameco, I use DigiKey.
I use DigiKey primarily.
DigiKey has they just started doing first class mail shipping too.
Yeah.
So you can pay like $2 and depending on where you live, get it within a day or two. Which
they're
is awesome.
fast. Yeah, it doesn't work for me.
The fun thing about DigiKey was
you guys don't count.
The fun thing about DigiKey for the longest time, for those of you who aren't, how many of you guys are from DigiKey, right? Okay.
Yeah.
How many of you used to get their catalog sent to you, and it's like that big ass phone book?
And it was this.
Yeah,
I complained
and it
when
got
we
bigger
stopped
and bigger.
sending those.
And they used to come with stickers so that you could tag the pages because there was so much shit in there.
When they stopped making those catalogs, I complained. I sent a message to them and said they should keep making them.
Keep making the.
I guess I'm against the trees or something, but I like having something that I can like flip through and actually look. Like I really use that catalog.
Yeah.
Well, that's the only way to find connectors. I mean, chips are chips.
Oh,
but if you're going to find a connector, try to find a connector on a damn parametric search.
All right. So, Thank you. Next question.
So I'll out myself. I love my Arduino. I'm sure most of the people here are here because they got started on Arduino. Show of hands.
Yeah. Oh yeah, good idea. Who's used Arduino? Yeah.
How many people's first
Who's going to admit to using the A word?
I will.
Right.
Not that many.
How many people here their first experience was like a basic stamp?
Oh, that was my first.
How many was like pick?
Cool. Wow.
Yeah.
I actually started.
Really quickly, I want to interject this before you ask your question. My first experience with a PIC was hacking your hex code from the Defcon 14 badge.
Yeah.
I was the only one who successfully reprogrammed that goddamn badge, and I did not win the badge hack. I have a bone to pick with you.
I'll have to review the contest entries and
That's
maybe
right.
I can
Yes, you will.
give you an
Some
honorary
asshole would
mention.
like put a modified cigarette lighter behind it and made a flamethrower out of it.
Did he win? No, he didn't win that
No, it was
one.
the guy who had the audio. That was
Yeah,
pretty
yeah.
cool, I admit.
I'll have to review the notes.
Sorry, go on.
So no. So I've got an MSP launchpad at home. I started off on an mbed and 32-bit beefy. That thing is awesome. But going back to the Arduino and just kind of back to the hobbyist artist thing, SparkFun, Adafruit. Do you think? Yeah, definitely.
Love SparkFun.
Oh yeah,
Good stuff.
So the drop-in hardware, the Lego kind of, I can drop it in, copy the code from Adafruit, from SparkFun, compile it, run it there. Do you think that's devaluing the industry at all?
No,
Not in
no
this
way.
list.
No, I love the. Oh, sorry. I mean,
No, go ahead. Go ahead.
I know the guys over at SparkFun. I love their stuff. Ada's stuff shows up all the time. It's great. I think it's helping people that wouldn't be able to accomplish certain projects because it's making it Lego. Slap the pieces together. I mean, especially thinking like the lily pad with the folks that are doing the clothing hacks and stuff like that. I think it's opened up that world to people who otherwise couldn't get through that barrier. The same way the Arduino and the stamp both made both the PIC and the AVRs accessible to people that weren't otherwise.
Okay, and if I can just interject a question on that, one of the big things I've always found is just some of the tinkering with stuff to do in the goggles and that is you've built it with a basic stamp, Arduino, whatever. It's taking you to that next step where I no longer need all the accessories. I just need the chip and everything like that. My problem has always been, where the hell do I figure out how to do that? Because it's like, how do you rescale?
Are you trying to make a product, or are you trying to make stuff for you? Because that's two
Just a
different,
one-off.
Yeah,
Just one-off stuff.
Like a more refined thing.
You don't want to have a stack of shields this tall. You just want to have a single board with the stuff that you need. Yeah.
I think I want to answer that, but I want to say with with respect to like Adafruit and SparkFun and all these places, it doesn't only help the people getting into it, and it doesn't only help the hobbyists, it helps all of the professional engineers that don't want to go through the time of spinning a board to try a new part, right? So they're making footprints and breakout boards and all these things. That saves a ton of time for everybody. So it definitely doesn't hurt.
It's great for prototyping as well.
Yeah, proof of
I want
concept.
I want to have this particular chip with this controller and see if I can make this product work. I'm going to do it first with all these shields that are already built, slap it all together, make it work, and then say, okay, I've proved the concept. Now I'm going to go design and fab a board that has just these three components that I need instead of a stack of shields this tall. It is now a board this big.
And that's what you're asking, right?
Yeah,
How to distill it.
Step two.
How do you distill it from all the crap down to only what you need?
Hey, Render, you hire me. Okay.
But if you don't want to pay money, right? Yeah, I mean, I think it's, at that point you need to look at the schematics of every individual module. You have to see which pieces you're actually using. And then what I tend to do is like take all, I have a big prototype of all the crap, and then I identify which parts are useful, create a smaller schematic, and then just get a board layout package that, whatever you're familiar with, or if you're not, you could use KiCad or DipTrace or Eagle or whatever. I use Altium Designer, but
I'm a fan of Altium.
that's
myself.
more expensive. And there's a free version of that.
There
or a
may
trial
or may not be
version.
torrents of Altium.
And then you can go spin your board, use oshpark.com to get your boards fab. It's like $1 a square inch or something. And experiment. And because it's so cheap, if you fuck up the board fab, you just do it again and you wait a few more days to get another one back.
Am I going to get kicked off the panel if I admit that I use Express PCB?
No, not at all.
Okay,
In fact,
good.
I know a lot of people that for prototyping purposes, but there are some not released. So the way PCB Express and a lot of those guys work is they'll release their own proprietary design software, but then they don't give you the actual Gerbers. They create the Gerbers in-house, and that's how they kind of lock you into using them as their service. I know of at least 2 different groups that were writing stuff to take the stuff that their software produced and actually give you your real Gerbers.
Sweet. Nice.
So
It's like a jailbreak.
yeah, it's like
for Express
jailbreaking the
PCB.
design process.
But Express PCB is a great service because they have their own software that is not nearly as complex as Eagle or KiCad or anything else. It is so incredibly dead simple to use to do circuit board layout. They can do 2-layer boards, 4-layer boards. They can do a silk screen on the top, not on the bottom, unfortunately. And then once you have the design, if you can keep your board to 2.5 inches by 3.8 inches, then you click a button and give them, I think it's up to about a little less than $60 right now if you don't need a solder mask, or I think 70 or $80 if you want a solder mask and silk screen, for 3 boards, and they will get them to you in about a week. So it's an incredibly cheap way of prototyping. I mean, 2.5 by 3.8 is not a tiny board. It's not huge, but it's you can fit a lot on that amount of space. And it's a great way of just getting in and like, I'm going to draw traces from here and kind of connect these pins, and you don't have to worry too much about making it nice and clean because you're not making a product. It's just a prototype. And the service is great. I've never had a problem with them, and it's really inexpensive. Osh Park is also a great way of doing it expensive, but I think they have a much longer lead time at this point.
I think he runs boards now like every other day or something.
Does he really?
Yeah, and I think that laying out boards is a completely different discussion, but for the most part, if you're doing a prototype and it's not something that has specific board layout requirements, you can get away with a simple tool. I do want to mention too, for you Canadians out there's AP Circuits. Right? AP Circuits, eh? Yeah. Someone's like, yeah. So you can use AP Circuits, Alberta printed circuits, and it's a similar type of, prototype quantity, simple board fab type of house.
They're expensive, but they're fast.
Thanks, guys. But they're Canadian.
Yeah,
they're Canadian.
Crapped on shipping.
They ship to the U.S.
Apparently they ship to the U.S. too.
Yeah. Okay. Go for it.
I'm not afraid to ask dumb questions.
We're not afraid to answer them.
Oh, excellent. I bought 2 boards literally like a week ago, little development boards. One was the BeagleBone, and the other was, I think I just went to YouTube and searched on embedded programming and found some guy, statemachine.com, I think, who did a 9 series lecture on using the TI Stellaris Launchpad, walking you through like writing a C program to blink the LEDs and that sort of thing. I guess the first question is, are those microcontrollers, or are those sort of bigger than
So the BeagleBoard's a great board. I like the BeagleBoard stuff. I don't know if you guys have any thoughts on those.
I would consider those modules, right? I mean, there's microcontrollers on them.
Yeah.
Well, no, the distinction that I think he's trying to make is that they're not microcontrollers, they're CPUs. I mean, there's this very subtle distinction between a microcontroller where you are writing assembly or C or something that's running directly on the chip.
Timer.
What's that?
Well, Intel considered, yes, there was an 186. They considered it a microcontroller because it had timer on board.
Because it had timer.
I always thought it was.
Didn't have A-to-D,
I always thought a microcontroller had onboard peripherals, so memory and things like that on board. You don't have exposed buses going to outside stuff. But then a microprocessor was just the CPU, where you needed to have everything external in your memory mapping and your address and data bus switching, all that. That's how I always talk about it.
But when you're talking about things like the BeagleBone and the Raspberry Pi, the main difference there is that you are not necessarily writing code that has 100% control over the CPU. You are writing an application that runs inside an operating system. And so it's a different in development environment. And I'm not trying to make a religious distinction here. They both have their place. If you're a software guy and you don't want to have to worry about how to write a bootloader, and you just want to have something that does some stuff, and you're comfortable with GCC and you write applications in Linux all day, then put Linux on your chip, or put Linux on your embedded environment, and that's fine. It's gotten cheap enough that Dr. Moore solved that problem for us, right? The reason we had microcontrollers is because they were smaller and simpler and cheaper when a full CPU was so much more expensive. That is no longer the case. We can now throw transistors at these things, and the cost is no longer the problem. So we can put an entire Linux operating system on this thing, and it's still $35. An Arduino costs about $30 to $35, depending on where you buy it, sometimes cheaper. The Raspberry Pi is $35. What's the difference? Well, the Raspberry Pi has a shit ton more resources, but it also needs it because it's running a full operating system. All right, so it's no longer a matter of which one is better, because they both have their place. It's really a matter of which one suits your application better. So the answer to the question of which one is better depends on what you're trying to do.
And a lot of that comes down to like high performance timing and things like that. If I need to get down to the hardware level on something like that's when it becomes more important to be able to get down to that level and have a tighter control.
Yeah. Most of you guys don't say interrupt latency probably as much as we do.
So would you rather write a custom application that just runs natively on the hardware then, as opposed to writing a device driver for Linux?
It depends on what I'm doing.
It depends on, it depends on the application. It depends on what you're trying to do with it.
I mean, think about a robot. Do you really want an OS controlling your motors on a robot? Or do you want something that's very simple, very predictable, where you know exactly, what you can do to take control of it? Oh, I'm not waiting on, this to message that and for the OS to decide to come around and then turn the robot off before it drives off the cliff.
Well, if you have, that's
but at the same time,
if you have if you have like a good deterministic RTOS or something, that's fine for embedded. It's not like you're running, you could run Windows on an embedded device. I wouldn't.
Christ.
But
I got friends at Willow Garage who would shoot you for that.
And normally you would just have a simple state machine, depending on the product, right? It all depends on what you want.
I'm surprised nobody brought VxWorks up before now.
Yep.
So, like in the robot example, I would put the motor controls on a microcontroller, but then I would use something like a Raspberry Pi or a BeagleBone to maybe do the route processing and the high level decision making process and taking in of video stream data and doing an analysis of what's going on around me. But then have it send a signal to the microcontroller and say, turn my wheels on going this speed for this long, and then have the microcontroller that has the very precise timing actually control the motors. So that's the kind of decision making process that you have to make at design time of what is it that I'm trying to do and which of these platforms is better for that particular task.
Yeah, and it was just briefly mentioned here, the dreaded word that nobody likes to just deal with is dealing with interrupts and interrupt timing. And I think that's why we're now breaking into this point where we've got even what I would call a microcontroller with multiple cores and things like that, like the propeller. Is because of then you don't have to deal with time slicing and interrupt problems and loop timing and things like that. And I think we're starting, and even further than that, I think the real future for all of this is going to be what we see coming from the FPGA world.
Sure.
Yes.
Thank you.
Thank you.
Next up.
Hi, I'm really happy to see all the embedded stalwarts here experience, and I thanks Miri for putting up this panel. Really, my question to you is, I'm an embedded system student, and being I want to be in this field for professionally, not a hobbyist, but professionally. So. Earlier, it was like if you're in microcontrollers, you should know sensor interface, you should know actuator interface, and you should know basic control logic design. That was the basic thing in my stereotype in my mind. But now the time has changed a lot. That the programming part, the control logic part, has evolved, and it's reached to such high level that you can do software systems, you can do database systems, you can do network systems, you can do controls, like all the systems. So. PCB designing and schematics and sensor is still there, actuator is still there. My question to you all is as as embedded systems engineer, what are the basic things which at least I should know firmly? I hope I'm clear.
I guess you're just asking what is a basic skill set to enter into that world as a professional? Is that correct?
Yeah, the basic skill set, yeah. And what later on I can decide on my own where I'm interested in.
Well, I'm not the professional. You guys. Never mind.
I'm never professional.
Go ahead, Jim.
Oh, wow. Yeah. I almost feel like that's asking, how do you become a hacker? Yeah. To me, it's just a natural progression of hobbyists, building stuff, and then it's like, oh, wait. Helping out of the company, and then it's like, wait a second, now they want to hire me, and it's like they're paying me to just do this stuff. So I think a lot of it is once you get your foot in the door, if you already named off a lot of the things that are important. Once you find a company or a project that you're in love with, you just start doing it, and you will just kind of gain stuff. And I don't really know what's the best thing to know, but especially if you get into a company, the hands-on, the real world experience that you get from working at an actual company that works with embedded systems, whether it's a product development company or whether it's a specific product not consulting, whatever it is, that's where you get the best experience. And so I think as long as you kind of, love what you do and you learn more about all those things you already said, it's just kind of this natural thing. I don't know if there's any better way to explain it.
And I know I've been giving this answer a lot, but I think it also depends on what the application is that you're trying to do. So what kinds of general skill sets? Well, obviously electronics. If you're going to be doing microcontrollers as well, then some programming would probably be good. The lower level, the better. Understanding of how assembly works is going to be important.
I would second that.
Here's the big difference. I mean, between embedded guys and, pure software. Speaking as a hiring manager, and okay, here's a skill set that I would list if I was doing, the official thing, and then I'll tell you what the kinds of people I really hire. But, big difference, physics. Because, okay, you're going to be turning motors and interfacing with sensors and talking with people about, what this frequency of whatever or this coming in, and I need to turn it into, this real world thing, and I'm going to turn it into software somewhere. So understanding the physics behind that is far more important than, again, pushing packets around. When it comes down to hiring people, I had this one kid, and we were interviewing him and went through, and, what'd you do last summer? I rebuilt this Chevy 350 just to understand it. Shit, you're hired. Because I want somebody that does hands-on. I mean, in the embedded world, you've got to touch the hardware. Yeah.
Exactly.
The one big question, have you ever brought up a new system? Okay, because, and that, again, it goes back to what I said earlier about doing hardware. Okay, if your code doesn't work, okay, you just recompile. You got a board. You spend all this money. You decide, okay, you're going to take this down. You're going to put it into one board. You've laid the board down. You put all your parts on there, which is a fucked up mistake. But you got this board, and you turn it on, and it doesn't work. Okay, now what?
Yeah.
And you've got to understand what's going on that board, and it could be something like, again, physics. It could be you laid it out wrong, and it ain't going to work. It could be the chip's not running, a trace was left off. Hands-on.
Yeah,
Just
being able to troubleshoot circuits is a huge skill that, and like when I was teaching at the university, it used to frustrate me to no end. Like I was brutally honest with some students. I'd be like, if they come to me and ask a question, and I would always say, "Have you tried it? Have you gone out and tinkerers? We need more tinkerers." And if they hadn't tried it, you don't have the mindset to be doing this type of work. And to be blunt, we need more tinkerers. And I know it's right now we call them makers, but we need more tinkerers. We need people that are putting their hands on stuff. I'm always championing in the embedded systems world. We teach kids from a young age that electronics are expensive, dangerous, and breakable.
Not anymore. Not with
but exactly. But in our community, but for the longest time, everybody. Just even look at the participation in the badge stuff here at Defcon. We have orders of magnitude more people involved in badge stuff if it's not electronic, because people just have that intimidation factor that haven't made that first step. That's why we have the hardware hacking village. That's why Defcon Kids is doing the electronic badges this year. And we need to continue to propagate and keep that momentum moving forward.
Thank you.
Thank you.
Just one more thing. When we were discussing about for getting started for a beginner, we were discussing about Arduino or Basic STEM, or the thing which I wanted to know is like, when I use Arduino, I have used Arduino. I've got the things done. But by using it more and more, getting deeper into it, will it give me that basic concept of which makes me evolve as an engineer? That if I get any new program, any new microcontroller in future, I'll be able to program it. I'll be able to hook up a programmer into it or something like that. I'm looking for something to get started in that way, which makes me able to later on work on any microcontroller and not just Arduino or...
Pick one. They're all different in little ways, and they're all the same in many ways. So just pick one and get started, and then learn it and get comfortable with it, and then pick another one and get started. Maybe you start with a propeller and learn spin. Spin's assembly is the most beautiful thing I've ever seen. I don't know if you were involved in spin at all. I'm sorry, spin is the
spin is the high level.
The high level, yeah. I'm sorry. The propeller assembly is one of the most beautiful things I've ever seen. I don't know if you were involved in that at all. Lost, but it is a great assembly. And then you take that, and then you maybe pick up an Arduino, and then you maybe pick up a an Atmel programmer and just start working on that, or maybe Freescale or something like that. But just pick one and get started.
I would be willing to bet that all of us up here have a closet full of dev kits and programmers for different environments.
Yeah.
Do you not?
I have a barn full of that shit.
But I think one advantage of Arduino, I think the question was going from sort of like renders of going from one to the module down. You want to start working with more at a lower level. And that one thing with Arduino is that, and you see this a lot, is because Arduino really is just the code that's running on the Atmel AVR.
On the AVR.
Right? So you can start with the Arduino platform board, and then if you want to try to refine that or go a level down, then you can just take an Atmel AVR and port or load Arduino software on it, and that use that. So it's slightly more refined. And then eventually you're going to want to get to the point where you have a microcontroller, or maybe you don't need to get to that point, but you'll have a microcontroller with just the stuff you want, and it's not a module, but it's a refined product that's just stuff you want.
You can actually go the other way. For those of you who are running the Darknet game this year, the Darknet badges, the software was written in the Arduino IDE, even though it is not an Arduino itself. The Arduino IDE is just it's just a front for GCC, AVR GCC. So it takes C++ code and turns it into Atmel code. And if you give it the right hardware files, you can find them online for the ATtiny85, then you can use the Arduino IDE just because it is so incredibly simple and program non-Arduino devices.
By the way, if you haven't talked to the Darknet guys, they did awesome work this year, and it's an amazing contest.
Thank you.
Go talk to them.
So we got 5 minutes left, and I want to bang through as many questions as we can here. So
thank you. Yep. Come on up, Noid.
Speed round.
Hi.
Hey.
So I started on the propeller, and I'm still on the propeller because I'm pretty addicted. So I've built a whole bunch of stuff, and they're all unique. They're all completely digital circuits. But I have a problem on one of my boards specifically where when I run it at 3.3 volts, I get data corruption on my UARTs, but when I drop it down to 2.8, everything works. So how would you go about starting to debug something like that?
You drop it works?
Yeah, it's bizarre.
That's fucked up.
I don't know. I mean, the first thing I would say is look at the signals on the scope and see if you're actually getting noise outside of the chip, or if it's something that's being caused by overvoltage or something else inside the chip. And then check, make sure it's noise versus parity issues. Maybe there's just some other weird configuration thing.
Yeah. It has an RF module on it, so noise, I guess, is possible.
You think?
Yeah.
Even something as strange as battery
physics.
placement. Yeah. That he goes back to exactly what he was saying. Welcome to the world of hacking your circuit or troubleshooting. Yeah. That's really one of the greatest skills that I think some people are.
As soon as you start talking about RF, Ryan was mentioning earlier, one of the things you should learn, it was firmware, is physics.
Yeah.
I bet you have a trace somewhere that is exactly the length of your RF, a quarter wave, your quarter wavelength trace somewhere that's just picking it up.
And you'll be able to visualize that on the scope, and then you'll know where to start.
You got to have a scope. I mean, trying to troubleshoot a board without a scope is like trying to troubleshoot code without a debugger. I mean,
it happens all the time.
Yeah,
There's startups that I've seen in San Francisco that kids have dropped out of school and moved to California to start companies, and they don't even have an oscilloscope to debug the most basic things, and it's mind-blowing.
Go get you an old Tech 465. You'll be rocking.
Yeah, I brought a logic analyzer with me, but that ain't going to help me. Thank you.
Yeah, probably not.
Yeah.
Oh, that's old school, old 465.
Okay. One question for one person up here. We'll just kind of keep the discussion going. And
nice.
Okay, what's with the porn music?
Is that all?
I think that's I'm telling us to get.
Are we done?
Are we done?
I guess I don't know.
15 minutes.
Is that the
get off stage music?
Nice. Dance party, everybody.
Keep going.
One person, one question. We have 4 more people.
Go for it.
Or Joe, just do lightning round. Just go quickly.
When you're making a decision designing, I would say, an RF signal processing board, which point are you drawing the line between saying, I'm going to use a DSP or an FPGA for this solution?
Not me.
I would lean towards a DSP just because FPGAs, when I think of FPGAs, I think of just the hardcore digital side of things, and DSP might just give you more, I don't know, maybe easier to kind of manipulate, if that makes sense. And you could always maybe port to FPGA, but I would tend to go with a DSP first.
Next question.
Thanks.
What can I do to help my young children? I've got an 11-year-old boy who's coming of age. What can I do to introduce them to this world? I don't have a lot of experience.
Go get the What's a Microcontroller kit.
What?
The What's a Microcontroller kit. Get it at Radio Shack.
What he said.
From Parallax. It's a Parallax What's a Microcontroller
But it
kit.
comes with a huge book that was written to help moving forward, and that's the difference between that product and any of the others, is the supporting documentation is a no-kidding book.
Can you give me a free sample?
Yeah.
He doesn't work for Parallax anymore.
I don't work for Parallax anymore, but I still think it's a great way to introduce people to it.
Yeah.
Oh, okay, I got a long list under my palm but very quickly, the two things I'd say, and I'm a systems engineer, I do mission critical embedded systems.
Awesome.
And I got started when I was 10 doing basic on a GE time sharing system, and then did 8080 in 76. So I'm an old fart. The two things I'd say is the tool chain, the Atmel and the Arduino gives you a solid, reliable tool chain. Stay away from the CCS compiler. It should be chucked into the heart of the sun. I lost 60 hours of my life on a professional project because of the friggin' CCS compiler on a PIC-24. The other thing I'd say, I haven't heard
table for one.
Learn C.
Yes.
Yeah.
Okay?
Oh, yeah. I second that.
And keep your code simple.
Yes.
I would say learn C, and then learn assembly. And to be fair, the CCS compiler is good for certain things. I found bugs in that compiler too, but then when you do, you get free subscription for longer.
The ninjas are getting restless here. I think they're going to start throwing spears at us, so we got to wrap it up.
I want to make one comment to that. I tell everyone that's just a programmer, do some embedded system stuff. It will change the way you program.
Oh, yeah.
So
Because you figure out what the fuck the machine's doing.
All right, thank you very much.
Man, this one
is awesome. Thank you.
Thank you.
sale that I was the one that was actually looking at him with John Barrowman.
I know, yeah.
And so
Ryan was in control of my destiny.
That's how kind of Joe and I met. And so like before we met through Defcon, like I was looking at his products, I think it was the GPS module.
Probably a GPS.
When we were having that
before GPS was easy to deal with.
Yeah, and we were standing outside, and I think was it John Williams that was busting your balls about something? I just remember a funny interaction that we had, and you were going.
And I don't know. I think Ryan was at DEF CON and I was at DEF CON, but I don't know if we knew each other. And it was like, you work at Parallax? Weird. But yeah, it's a small, sort of like the embedded world is kind of a small community, I think.
And for the record, I do not work for Parallax anymore.
No.
So I think the first question for everyone. What?
And this guy over here.
I'm good.
Here, let me give you some water. Hold on, have some water.
And the funny thing is Smitty is the one who put this whole thing together.
Yeah, this whole panel was my idea. I'm not sure how I got convinced these heavies to do this panel with me. My name is Mark Smith, or Smitty. I'm the only one up here who does not do microcontrollers professionally. So I'm a hobbyist with my microcontrollers. I spend most of my time on Atmels these days.
Thank you for saying Atmel and not saying the other A word.
What?
I'm sure it will come up.
Okay.
I'm waiting for that.
I spend the Arduino word. Mm-hmm. Yes, okay.
That will come up.
Ooh, good Lord, we got a bad reception on that one. But I got my start in computers when I was at a very young age. My oldest sister got a TRS.
Applause, please. So I got started with computers and electronics really early. In 1982 with an Atari 400. And my brother was luckily interested in this type of stuff. So he sort of threw all these tools at me in electronics, and it didn't literally hit me. But I kind of was exposed to a lot of electronics at an early age, which was cool. So I first started getting involved in kind of non-microcontroller development, so making boards for red boxes and blue boxes and various phone freaking stuff.
I think the statute of limitations is up. We can talk about it.
It's probably up, yeah. But I got involved in embedded development kind of in my teenage years and then in college. So I was sort of a Motorola HC05, HC08 guy for a while, and then got involved with microchip PICs and sort of stayed with those. Motorola spun off into Freescale, so I went over and started using Freescale stuff. But if you guys noticed, for Defcon 14 badge was a microchip PIC, and then 15 through 18 was all Freescale, and that was mostly because they would just take me out to dinner more than microchip did. So yeah,
fastest way to Joe Grant's heart is through his stomach. Free food, pretty much, guys. So remember that. So
I sort of specialize in embedded system development of kind of low end consumer and household devices, and then of course I do hardware security. I break stuff once in a while too.
Yeah. So interesting side note, Joe. Do you realize that some of the products that you would submit to Parallax for?
Well, I started hacking code on an Altair 8800B, and like a lot of you guys, I loved writing software, but it's like I wanted to do hardware stuff, and so I ended up with back in the day of 8051 microcontrollers, and that was all for fun, and ended up being an embedded systems engineer, making my way up to being a VP of engineering for a contract design house. So I love making hardware that does something, and some of it has blown stuff up, and some of it has helped people live, so it's probably a good balance.
Kind of a 50-50 thing there.
Kind of a net zero.
Yeah.
So my first foray into the world of microcontrollers was with the Motorola 68HC11. Anybody in the audience remember that chip? Yeah.
Oh, yeah.
We just dated ourselves, right?
Yep. Yeah, the 80s called, they want their street cred back.
So I've just always been interested in how things work, not just electronics, but just things in general. As a kid, I was always taking stuff apart and occasionally able to put it back together, usually things hacked to have different functionality. I've had numerous jobs over the years. I've worked for Parallax. I've worked as a design consultant for companies doing embedded systems, and specifically embedded system security, because that's kind of where my interests lie. So.
And you have some experience with some badge design.
A little, not as much as Joe.
Not yet.
Not yet. Working on that.
Me? Okay. Yeah. So I'm Joe Grand.
TV's Joe Grand.
TV's Joe Grand.
So please, no
Sadie Model 1. Can any of you beat that?
Yeah.
Actually, no. I think the 8800 beats that. Yeah. So I started on that just doing basic. I didn't get into assembly until college in the early 90s. My first microcontroller work was on an 8051, but I didn't spend a lot of time at Intel because Intel assembly sucks. So I'm a hobbyist. I am a network engineer and system administrator by trade, and I just do this on the weekends for fun because I like making stuff and I like making things that work. And I've been into electronics for a long time, and then once microcontrollers started getting really cheap in the 90s, that's when I got into adding programmability to my projects. So,
okay.
Yeah. So, and thanks for putting this panel together, by the way.
Thank you. Yeah.
Yes. What was that? Shit, you're welcome.
So everyone who's not played with microcontrollers or is just starting like I am, initially it's the question of where do you start? Because it is such a huge field and so many platforms, so many development tools out there. How the hell are you supposed to know where to begin? And I know some of you guys actually like teach classes on this. Where is a good place to kind of start and learn this?
Should we just go down the line?
Okay.
Or let's just talk.
Okay. Yeah. Well, yeah, I think that's definitely like people come up to me and ask the same thing. It's like there's so many different choices, and the good thing about nowadays is that there are so many choices, right? Like back in the day, if you wanted to.
All right. So, as many of you know, I'm RenderMan, and I have a distinct pleasure of moderating this panel, an introduction to microcontrollers. And I cannot believe that like every seat seems to be filled here.
It's pretty crazy.
So you probably
The pressure
recognize
is on.
what's that?
The pressure is on.
Yeah, I mean, I'm not wearing pants, so this just gets a lot more interesting.
Flirt with your wife.
And your crotch is right at the level of Joe's giant red fist.
Excuse me a moment.
It's going to be one of those kinds of panels, apparently.
Yeah, you don't want to know what's going on behind this podium here. So on my left, is that my left? Yes, that's my left. We have firmwares. We have Lost, who everybody should know, and I have a personal grudge against for the number of years of torture from the Mystery Challenge.
Oh, yeah.
All right, we got Smitty Halibut on the end here, in his very epic hat and custom-made vest. And Joe Grand, which...
I'd like to correct that render. That's TV's Joe Grand.
Oh, TV's Joe Grand. Yeah, Discovery Channel. Yeah.
Yes. Thank you. Please, no applause, please.
So we're basically here talking microcontrollers. I'm like elated because I get to pick these guys' brains for an hour here. That is something I would have like killed for at any other time. So basically, we're just going to go down and just sort of have everybody sort of introduce how they got into micros and just sort of their history, and we'll go from there. So, firmwares?
Wow. So